Listen, 16.16 is arc length. First, we're going to start out with fractions or parts of a circle, and that will help us build onto our arc length. Directions say the figure below shows part of a circle, so it's a section, or they call it a sector. Has a central angle as marked. What part of the full circle does the figure represent? Express your answer as a fraction in simplest term. So basically saying that this is a wedge of a bigger circle. And it's 60 degrees is that chunk out of a total revolution or circle of 360 degrees. So 60 degrees out of 360, you should be able to do that in your head, but if you couldn't, you could do 360 divided by 360, get your decimal, go math, enter, enter, to change it to a fraction. It's 1/6 of a total circle, right? It takes 6 of those wedges to make a total. Okay, number 2 is a bigger section, but we're still thinking this is 230 degrees out of a 360 degree total circle. So let's do 230 divided by 360. Math, enter, enter. That is just 23 of 36. So really we just divided out of 10. So it's 23/36 of a circle. Number 3 says the figure below represents 1/3 of a full circle. Find the measure of the marked angle. So we're saying it's 1/3 of, whenever you hear of, it's multiplication, 1/3 of 360 degrees, which think you multiply straight across, or you can divide diagonally. That's 360 divided by 3, which 36 divided by 3 would be 12. Add a 0, it should be 120 degrees. So 120 out of 360 is 1/3 of the circle. Number 4, I don't know why that's gray, but the figure below represents 5/8 of a circle. So 5/8 of, or times 360. You could simply do 5 times 360 divided by 8. $225 degrees. You can also think of dividing this. 360 divided by 8 is a 45. 5 45s makes 225. Okay, so using that, arc length is simply sectioning up a circle or having a sector inside a circle, and they want just parts of the circumference. So arc length formulas should make sense that you're putting the angle, we've talked about this before, the symbol's called theta, but that's just the angle in degrees, out of 360 times 2 times pi times r. You should recognize this as circumference formula. So we're just doing a part of a total circumference. So number 5 says, in circle C with measure of angle BCD equaling 98, and BC is 4, find the length of arc BD. Round to the nearest hundredth. So we're saying we have a sector, a part of a circle that's 98 degrees out of 360, and we're going to find that part of the circle, and then we're going to do circumference. I don't know why I said that word. Circumference, which is 2 times pi times the radius, which is 4. Okay, so let's figure out what part 98 is of 360. Math, enter, enter. It's 49 out of 180. Times 2 times 4 is 8 pi. Nearest hundredth, so they want us to figure out that as a decimal. So remember, you multiply straight across, take 49 times 8 pi. Go ahead and hit enter, then divide that by 180. Is 6.84 units. So that means here, if I were to take a string and stretch it around just from point B to D and then straighten it out, put it against a ruler, that's about how much it would be, which makes sense because the radius was 4. This looks longer than the radius. Okay, let's try one more. In circle B, BC, so that's a radius, is 11, and angle CBD is 20 degrees. So it's a little itty bitty wedge. Find the length of arc CD. How long is this here? Express your answer in a fraction times pi. So this time they want us to leave pi in it. So we're going to say that it's 20 degrees out of 360 times our circumference formula, 2 times pi times the radius is 11. Okay, so you don't even have to simplify this first if you don't want to. You could just do your 20 times 2 times 11. Multiply everything except for the pi. We'll tag that on at the end. 20 times 2 times 11 should be 22,440. Then divide by 360. Okay, math, enter, change it into a fraction. 11/9 times pi means 11 pi over 9. So you could do it like that, or if you wanted 11/9 of pi, you could write it like that. So be careful of what the directions say. Either they want it as a decimal or with pi.